Good afternoon, everyone. I'm here to welcome you back to the afternoon session, the plenary session after the exciting breakout talks and sessions over the lunch break. We hope you had a chance to refuel during lunch and enjoyed the impressive displays at the poster session. My name, for those of you who don't know me, is Edward Hallrott. I'm the Alva Owe Professor of Medical Science in the MCB department at Brown University. And I also had the privilege and great pleasure to have served as the program coordinator for the last 10 years for the Rhode Island Advanced RI-CTR NIH Award. We've had an intellectually packed morning from Dr. Murphy's insightful keynote on reinforcement learning algorithms, all the way to the incredible energy of our 12 lightning talks and the poster sessions. But for those of you who think the momentum's going to slow down now, you're wrong. We will not have a postprandial pause. As we head into the final stretch of this afternoon's program, we will be shifting our focus towards some critical conversations that define the future of the field. At the spotlight as to what's coming up next, first, there will be a panel discussion entitled What Works and What Matters for AI in Biomedicine and Health. Second, at 3:30, we will have our afternoon keynote. We are honored to have Dr. Suresh Venkatasubramanian join us to tackle a question that is likely on all of our minds. Can you or should AI, or should AI do my research? And at 4:20, we have on the schedule the award presentations. We will wrap up the formal programming by recognizing the outstanding work from today's lightning talks and posters, hence the array of awards up here at the front. But before we dive into the panel, I want to remind everyone that in conclusion of this day's activities, we will have a cocktail reception and networking hour starting at 4:30 p.m. It's a perfect time for us to follow up on those conversations started out during the course of the day. So thank you all, and I should mention that we have a record-breaking attendance of at least 170 in attendance. So I think this is a great accomplishment. Thank you all. So thank you for your energy and engagement, and let's get started with our afternoon panel, which will be moderated by Dr. Neil Sarkar.
Great. Well, thanks, Ed. I'm going to ask the panelists to come up while I make some introductory remarks. So my name is, can you hear me okay? My voice is usually not one that does not have an issue with not traveling. Okay, so my name is Neil Sarkar, and I will be moderating this afternoon's panel on what works and what matters for AI in biomedicine and health. And I would be remiss as someone who works in the space of AI and not try to use AI to make this presentation. So when I was first asked to think about this, I said, well, why bother having humans up here? I could do the whole thing with just having AI do it for me, right? And so I took this first slide, I took a version of this first slide, and I gave it to ChatGPT, and I said, well, this is kind of boring. Can you make it a little bit more exciting and actually make it into a graphic? And if this works really well, then as much as I like these folks, they're great, and some of them have been dear friends for more than a decade at this point. I could ask them, I could see them after cocktails and just have the AI deliver the talk, right? So I gave ChatGPT this presentation slide, and there's two things. So for those of you who are paying attention, those of you who are editors would know that on the first slide there was a typographical error in the first word. So it fixed that. That's good news. This is a good sign. AI is making my life better because it's correcting my typographical errors. So what works and what's not. It's made a really snazzy graphic. And clearly the AI thinks that the human is not important because you will notice that it removed me as the moderator from this slide. Now, mind you, this is just one iteration. I could go through and maybe fix it. And I said, well, that's just going to be a lot of extra effort. And so I decided to go back to the original plan and actually invite the humans to present on AI, where we're at, where we've been, where we're at, and where we're going. And that's basically going to be the first part. We have Nick Fisk from URI, Zhicheng Jiao from Radiology, Matt Butler from Brown Health, and Paul Stey from Brown University, who'll each give 3-minute presentations on, from their perspective, where have we come from? where are we at right now from their institutional perspective, and then what does the future look like? And then if all that times out just right, we will then have ample time for discussion, and I'm hoping that that all of you have at least one question to ask of our expert panelists, and if not, we have backup questions that we can navigate through. So I will actually just pass the remote, the Bobby thing to Nick to sort of go through his presentation, and we'll be very efficient with time.
Yeah, just sit here.
Yeah.
Great. I need the mic now. Yes. Hello.
You good?
Great. Yes, hello. I'm Nick Fisk. I'm representing University of Rhode Island. And I want to start talking about how we got here. And each of these slides is going to have a sort of 3x3. My research focuses on cancer evolution. I serve on the steering committee for AACR's Cancer Evolution Working Group. And so if you know much about the field, phylogenetics sort of predates computational biology, despite the fact that the earliest algorithms in biology were indeed phylogenetic. So before we had computers to run the algorithms, we had theoretical understandings of how we might infer a phylogeny, even without a molecular understanding of DNA, which came next in all the sequencing modalities, including in cancer, and even things like DNA melting assays, which are not done so much now, but were important iterative steps on the pathway to a molecular understanding of biology, but in particular of cancer. And then we got to the point where the data was a manageable size, where we could have, rather than supercomputers, we could have large lab computers to do some alignments and understanding of these molecular things. So this is kind of the past, how we got here. My sense of the state of affairs coming from somebody who works in the cancer space, the evolution space, and in this positionality that I occupy at a state university without a med school, we are now able to understand better what's happening in the unobservable past of a tumor via methodologies like subclonal deconvolution methods that are empowered largely by molecular advances, but somewhat by computational advantages needed to understand them. And then you have what I would consider semi-multimodal integration. So in this case, for neoantigen prediction, people do experimental design, and it used to be that you could have a series of experiments and try to predict the properties of somatic mutations leading to neoantigens. And that was all well and good, but now you have groups trying to incorporate other kinds of information, such as structure information as embedded in graphs, and try to do a multimodal synthesis to improve those predictions. So I wouldn't call a true integrative approach, but certainly getting there. And then you have efforts, and I have to do my own plug here, right, to contextualize what we're doing by incorporating the medical record explicitly with some more classic biology. So this is a patient's evolutionary tree of their tumor and how it progressed, how it responded to treatment, and that sort of thing. So with that in mind, where are we going? I think the two main things I'd be excited for, one that everybody's probably thinking about, is true multimodal integration, where you're not just doing one or two data modalities, but you're looking at massive parallel modalities that you're incorporating to answer specific questions. Some people might think of this as foundation modeling, but there's lots of ways to go about it. And then specifically for my subfield, I also had the idea to have AI, try to make the graph here, and I think it was quite salient, but treatment forecasting, predicting what changes the tumors are going to acquire, and changing therapy before the tumors recur to maximize the chance of extinction therapy. But of course, at the moment, AI is just barely missing the mark. So that's me. Thank you.
And Zhicheng's next.
Thank you. And I would like first to thanks, my great thanks to the CTR program, because I got funded 4 years ago, and it's my first opportunity to be a PI, and give me a lot, confidence. And then, I get other funding from the federal, also from other foundations. Really appreciate that support. Yeah, I'd like to begin with a very famous thing from the AI godfather, Professor Hinton. He gave this about 10 years ago to the Radiology Society that we don't need radiologists. At that time, I was a PhD student. I'm studying something like, using a training AI model to distinguish from the benign breast tumor, from the benign breast tumor to do the diagnose. at that time point, I kind of like, agree with him, because my first project is, classify if this breast tumor is benign or malignant from the mammogram image. And, the accuracy is something like 95% or even higher. But after that, I realized I'm wrong, because when I work closely with radiology, I realized, when I got the data, they already get 95% work done. And they label the tumor first to contour that. And then I get the tumor image path and do the classification. When I apply that to the raw data, the performance is far behind the radiologist. So that, actually bring me more opportunities like in the previous years, we don't have that many radiology departments have a full-time AI research lab. But nowadays, I think not every, but almost every, department of radiology have an AI research team and an AI translational team, because AI software and AI products are everywhere in our field. And, motivated by that kind of thing to the radiology society, radiologists, they don't, be afraid of, AI innovation, but they double down. And we can see that from the statistic of the FDA cleared, AI products. Almost the, the largest majority of them is, from the radiology department. And other things like the cardiology and many of them also the image-based software or hardware. So this brings, our department a lot of opportunity, like, research and the full pipeline or the workflow of the radiology. From, the scanning, we can get a higher resolution image from the same, imaging scanner with the AI algorithm. We can also do something like a higher accuracy tumor quantification, and also do the, disease diagnose, prognosis, and provide more reference for the radiologists. And they are enjoying a better life, with the help of AI, but not being taken over. And now, a very good thing is happening is Professor Hinton, slightly modify his thought. Like, the future should be, human-AI collaboration. And that's also the reason, we establish a Brown imaging core that, we want to empower, other department or other friends. Like, we have been working closely with the BCBI. We're also working, a lot with the, Cancer Center and the Matt Butler's team to do some AI infrastructure thing. And also, other departments that like the neurosurgeon, neurology and cardiology. And, and I think every department needs imaging. And every department, try to translate some imaging AI method into their research and daily practice. And I just checked in our system. We established the Brown imaging core for only 6 months, but we already fulfilled something like 594 different imaging requests, and each of them covers, up to dozens of imaging cases. And that's, I'd say, every research and every, translational research should be the human-centric. So the future should be, the AI evolve itself to adapt to the human need. And, AI will replace itself if it can, cannot meet the human need. Thank you.
Good.
Matt's going to be next. Matt's next.
Thank you. So pleasure to be here. Matt Butler, I'm the Director of AI for Brown Health. I'm going to go over the past 10 months that we've had at Brown Health, as I've been the inaugural director of the AI Center of Excellence. And so for the first 6 months, we were really focused on let's pour the responsible AI foundation for the health system. What does that mean? Let's put in the right governance structures. We have a wonderful governance council with representation from across the entire health system, an engaged executive AI board, and clinical subcommittees and business subcommittees to really focus on how do we bring AI to life responsibly. Then we set the policy for the system. I'm very proud of that. AI Governance Council was able to draft and publish out our first AI policy that covers all of Brown Health. And then we established the AI Center of Excellence to operationalize that policy and that governance and actually bring AI to life. Then we started engaging all different departments, all different leadership to understand what are the problems we're facing as a health system today, and how could AI potentially help address some of those issues, and then really understanding the landscape and the opportunities that we have as a health system. So that was the first 6 months. The next 4 months have really been focused on safe and responsible adoption and enablement of AI. And this is a process where we really want to look at how do we crawl, walk, run. So first of all, we didn't want to just put a policy in place and then say you can't use AI at the health system and not give anyone a viable opportunity to actually leverage it in meaningful ways. So one of the first things we did was we democratized access to large language models through Copilot Chat, which I know wasn't the greatest at the start, but it's continued to get better day in and day out, and it's actually moving the needle for a lot of our departments across the health system. Then we looked at how do we enable folks with more of the premium features of things like Copilot or ambient documentation for our providers. We've started to scale that across over 25 different departments. For ambient documentation, we've fully covered primary care and the emergency physician group, and we're looking to rapidly scale that across the entire health system. And then it was really how do we pour our agentic infrastructure and make sure that we at Brown Health can take advantage of our most valuable asset, which is our clinical IP, our clinical know-how, our clinical workflows, and actually be able to build Brown Health agents in a secure way that we could integrate back into workflow. Well, we've done a lot of work to start establishing that infrastructure. And then how do we start to support our researchers as well? And that's all through the work that we're trying to enable through the cloud, secure access to the large language models that are out there so that the best and the brightest can have access to the best and the brightest. So this is our enablement strategy from really across the Microsoft stack. Then we looked at our EHR, and we wanted to get started with all these wonderful new Epic features that are coming out to really drive down clinician burden and really make it so that a lot of these administrative processes are more easy to handle. So we launched our first wave of Epic Gen AI features in the fall. We, again, crawl, walk, run, started with only a handful of practices, but are now looking to scale some of those features. And we're about to kick off wave 2, things like intelligent chart summarization, being able to quickly draft denial appeal letters based on the clinical information within the chart and making sure that that patient can get the services that they need, making sure that we can use AI to generate medical necessity for prior authorization, cutting down the friction across our health system in meaningful ways that are embedded in the workflow. And where are we headed? Well, I am a big believer in agentic AI. I'm so excited about the potential of it. And we're going from being able to build a purpose-built agent to really intelligent agentic ecosystems. So across the health system, how can we start to embed PhD-level intelligence at every department so that everyone can have access to these wonderful tools and use them and innovate with them in meaningful ways? And I'm very excited about the future and where we're headed. And that chart was AI generated and means absolutely nothing. So that's also, I think, something to consider with AI that we're trying to work through from a responsible AI framework. But
Hi, everyone. Paul Stey. I work in the Center for Computation and Visualization at Brown. CCV is the university's research computing center. So what does that mean? Well, we house the university's primary supercomputer. This is called Oscar. We also house the university's sort of secure computing enclave. This is called Stronghold. We also have a bunch of data scientists and software engineers that work as a kind of in-house consulting group for researchers. So a common scenario is you're a PI, and let's say you have a postdoc, and they leave 1 year into a 2-year postdoc. You still have the money that was going to pay for their second year, and you still have the work that needs to get done. So you can come to us and say, hey, Paul, I need 60% of a software engineer for the next 9 months. And we say, great, we'll give you, Mary or whatever. So that's kind of how we work. In terms of where we've been, here's like a little outline of the past. Anybody know who these two people are? This is John Carmack and John Romero. I think the reason I show them is they're a couple college dropouts who started a software company called id Software. Folks remember id? No gamers. Okay, I forgive you. Okay, one hand. So maybe you've heard of Doom. Doom is a game that launched a genre. You've probably heard of 3D first-person shooters. I'm going to argue that 3D first-person shooters is one of the reasons we have the AI that we have today, basically because the industry sort of responded to the demand for these games. These games have like sort of really computationally intensive demands. The chip industry responded by creating a bunch of chips that do a really good job of rendering 3D graphics. it sort of turns out that the same math, basically matrix algebra that you use to render 3D graphics is exactly the same math that you use for all of science, including deep learning. So sort of, I show this to illustrate kind of the serendipity of where we are. Like it was not guaranteed. It's sort of almost accidental that we have the kinds of models that we have. And part of it is because of the gamers, frankly. So this is what we have in our center. So we have Oscar is our primary supercomputer. We have about 28,000 CPU cores. We have about 1,000 GPUs. We host 120 or 130 open weight LLMs on Oscar. It's free to use. We also have the AI sandbox, which you can check out at ai.ccv.brown.edu. It's got some sort of piloting tools. But yeah, we basically exist to kind of give researchers the tools that they need on-prem or in the cloud. Oscar's on-prem, but the tools that you need to do your research with AI. And in terms of kind of where we're going, it's hard to predict, but I'll take a shot. Natural language processing and computer vision are kind of the two areas that deep learning has basically completely disrupted. There's a person in our group who did her PhD in computer vision. It was about 12 years ago now. Everything that she did is completely outdated, and she knows it. I mean, it's just the field has changed very, very quickly. So I think I would propose that one of the next disciplines that is going to be kind of transformed is the sort of omics field. And you can see this already where NVIDIA is investing very, very heavily in the new, in basically software to do omics stuff on GPUs. And if you look kind of the history of the last 10 years, it's hard to bet against Jensen Huang. So yeah, I would say new, bigger models, bigger hardware. We're still at this interesting point. Folks remember Moore's law, kind of the relationship between time and transistors. So every 18 months, the number of transistors on the chip doubles. There's kind of an analog that's not yet named, but maybe someone will call it Jensen's law, where you have the size of your model, the size of your input, and the quality of your model. And that still seems to be scaling pretty well. If you get more data, you get bigger models, bigger GPUs, you get better output. So I think the scaling that we're seeing is going to, I think, continue for a while, and we're going to see more specialized hardware. This is a startup that is called Cerebrus. They basically make AI systems. So NVIDIA has absolutely dominated the space, but I think what we're going to see is more specialized application-specific integrated circuits, basically for deep learning and different sort of scientific applications. I'll stop there. That's more than 3 minutes.
Great. So in those snippets, we got the question and answer. So in that snippet, we gave you a fire hose of information, hopefully giving you sort of a tasting tour of everything that's going on in the spectrum of AI in the context of biomedicine and healthcare, largely because it's one of the sectors that's actually been way behind compared to some of the other sectors across industries. And so it's open now for questions. And so I'm going to sort of pause here and ask if there's any questions from the audience. If not, we have a couple of warm-up questions. Go ahead. Can you talk loud, or we have to get a mic to you?
I'm gonna run. Can you hear me?
You're good.
Awesome. Okay. For you at Brown University Health, how did you build incentive or foundational skills in utilizing AI for the faculty within or users within the hospital system?
I'd say it's a work in progress, and it really gets back into our crawl, walk, run approach, though. So being able to implement with what we call friends and family, so that would be a few providers to be able to get their hands on it, understand the efficacy of the solution, how effective is it, what are some of the pitfalls around it. And then we translate that, if it is successful, into a larger scale pilot. We are constantly, as we roll these out, surveying our clinicians and providers to understand what's working well, what isn't, and how do we adjust and iterate as we go. That also dovetails into our responsible AI framework. So very happy to have Grayson Baird here today. He has really helped us develop education to help upfront understand the risks of implementing AI, particularly in the clinical setting, and being able to tease that out as part of our intake process so that we're able to identify areas that we want to monitor ongoing and then incorporate that into our training of things to look out for and things to make sure that we're at least monitoring. So I think it's Overall, our goal this year is to launch an education program that would be able to have standard training for our clinicians. We've done some of that through lunch and learns and being able to teach to the policy and why things are in the policy, why you need to use secure AI, but we want to build out that curriculum further. And right now it's really, we're doing it as we roll out the pilots and getting our clinicians hands on the solution and then iterating constantly from there.
That's a great question. And actually, I'm going to ask Nick to comment on from the other side of the spectrum. So from the more biological side of things, particularly in, I don't know, phylogenetics or things of of that type, how do biologists go about sort of getting their training and sort of thinking about this in the context of AI?
Yeah, I think that there's a bit of a bifurcation, which is also a phylogenetics joke there. But because people who have already had their training and are still relatively active younger faculty, like seem to be picking up as a matter of course, often from their trainees, which is interesting. I think that exemplifies the sort of unique bi-directional way that science happens in that way. But I do have curiosities about how are we going to have people who are coming up as trainees now continue to develop the skills to ask good questions in the era of AI, and making sure that that all the incentives in the world exist to be creative and be inspired and to feel yourself as a citizen of the scientific community, and not offload that to the AI. While still navigating, the necessary skills that you need to evaluate the output of AI. Because I think there's a lot of willingness, but we're still working out vocationally what's acceptable.
That's great. We have a question over here. Yeah, go ahead, or a thought. Yeah, you too.
Thank you. My question was for Matthew Butler as well. I am really intrigued by your crawl, walk, run approach. And I'm curious about how you're thinking about interdisciplinary collaborations. So specifically as a health services researcher, I am thinking about something like the Epic Gen AI rollout as like a perfect mini RCT setup. But also you're still new at your job and we're all still figuring out how to collaborate. And so I'm curious if if you or anyone else has good examples of thinking about translational science in this setting, or other kind of working across clinical research, policy, and practice. Thank you.
Yeah, and so we tried to address some of that with actually how we set up our governance structure so that there is representation from leadership from all different areas. So on our governance council, we have representation from research, compliance, legal, community wellness, being able to have medical ethics, all on the same council helping develop the policies. Now, to your point though, how do you actually bring that to life at the project level or the use case level? Well, that's where we have those subcommittees that are supposed to be hyper-focused in their area, but are also meant to be multidisciplinary. And then I think we'll have more and more opportunities as we get more established with these use cases to bring folks in from, hey, this might be something that might be a QI project to start, but let's make sure that we're able to engage researchers over time and be able to set ourselves up for a more robust IRB study down the line. So I think we're 10 months in, we haven't figured out a perfect way, but we want to collaborate with folks such as yourself. The Center of Excellence is meant to be, right now we're a team of 3, 2 wonderful data scientists. We have Grayson, who's an honorary member, Atin Jindal, Dr. Jindal is an honorary member. We want to be as inclusive as possible. So if you have any ideas of how you want to work with the Center of Excellence, reach out and we'd love to talk through that. We're open to really any type of model that we think would work best for Brown.
And also in my effort to also deflect a little bit off of just so not everyone asking Matt, I'm going to ask Paul to talk a little bit about from a more generic structure. So as we think about doing research in non-healthcare contexts, how do we do this from the university perspective?
Yeah, I guess it's a good question. I think that we have basically taken the approach that everyone on campus should have as much compute as they need, and we try and give away as much as we can for free and to make it easy. We have a center with a lot of folks that are basically here to help. So there's kind of a continuum. If you look at like research computing centers across the United States, there's kind of a continuum in terms of like basically how much hand holding people will do. Like there are some centers where like they won't give you anything unless you buy a server, and then they'll take your server, they'll plug it in, and then they'll give you the root password and then wish you good luck. And I think we're on the opposite end of that continuum where we really try and help basically like every step of the way. So like as you're preparing your grant, as you're submitting your grant, we help, scope out hardware. We help scope out like percent effort of people time if you need a data scientist or a software engineer. So I think, and if you have specialized software needs, hardware needs, we really try and be very accommodating. So I kind of like to think that we give a very high level of like personalized service for researchers. I mean, we're here to help all of you. So that's what we're here for.
Great. Go ahead,
Yeah,
Gaurav.
I do second that because I've personally experienced the excellent customer service that CCV provides. Using Oscar, being a novice in this area, it was really helpful for me. But my question is, and I do understand some of the challenges of having systems in healthcare settings with HIPAA compliance and different versus the university settings. We are fortunate to have, many of us are fortunate to have more than one institution where we have access to compute resources. As you pointed out, things are only going to get more complicated and more expensive as far as compute resources are concerned. Over the longer term in a strategic plan, are there any alignment or complementary use of these resources that's planned? I do understand the logistical challenges of healthcare data, and the university data and how those are there. But as far as compute resources are concerned, and as far as things that we need to buy to make available to our researchers, we are not that big that we cannot, have a complementary plan that is strategically aligned. And I don't know if there are examples from other large academic institutions who have successfully implemented this. And I just want to know if, are we thinking about that, and how are we planning to go about it?
So I'll start. So we are thinking about that, and I am very excited about the next 6 months and actually hopefully the community feeling tangible progress on that front. We have a proposal out there right now to be able to establish a secure AI enclave in our cloud environment that will give us that broad access to a variety of large language models, but also be able to connect that meaningfully to our data. We have around 4 research use cases that we're going to get started to show the proof of value with that architecture. There are also a number of clinical operational use cases that we are going to use that same architecture to support in-house. And then that should give us a scalable architecture that we are able to enable the entire organization with. So it's very much, let's get started to show really the economies of scale of moving some of this to the cloud and being secure while we're doing it. But then that will serve us across a variety of research use cases, a variety of operational use cases, and a variety of business use cases. It is something that will be a huge enabler for the enterprise.
I was more thinking about, Brown University Health,
Yeah, so
Brown University, maybe another entity in our thing. Everybody's trying to invest in this space. There's only so much money. If people have access to more than one institutions, how can we align so there's less duplication and more confidence?
So hearkening back, actually, I think this is an excellent question and a point for all of us to reflect on, because actually hearkening back to Senator Reed's comments this morning, one of the most exciting things about being in an IDEA state is exactly that. We are small enough in terms of the researchers who are here. We are nimble. We are capable. We actually really don't have much excuse not to sort of work together within our IDEA community. And so what I would challenge each of us as we go out to the cocktail hour later today is find one partner who you haven't worked with before and say, how can we work together? And maybe it's in the context of AI, I hope it is, because that's what we're all excited about. And how can we partner around that? It's through those partnerships, and that's a common thread that brings this group together, is that all of us, including myself included, are infrastructure folks primarily. I mean, some of us have research agendas, and so we provide that infrastructure to support researchers. But the researchers need to come to us with those creative new ideas from across our community to see that work. And it was really exciting having been at University of Vermont before to see colleagues from Northern New England talk about what they've been doing up there, because that's sort of the next level up, is we can work together as IDEA communities in sort of scaling and figuring out where we are good at, what the resources that we have, and how do we partner together? But that does depend and rely on events like this to bring us together, to talk to each other, and ultimately to sort of build those bridges, because we can build it, but we need to know what we're building it for. Other thoughts or questions? So one thing that I want us to think a little bit about as a group is everyone's excited about large language models, myself included. I think they're great. But AI isn't just large language models. Turns out that that's an important piece of them, but there's other parts of AI. And so I wonder if each of you could comment a little bit about the non-LLM side of AI work that we have going on in our respective communities. That actually in many ways is just as important, if not in some ways more important, because they're sort of back to the basics, modeling and application in clinical context. Maybe we'll start with in the context of radiology. Zhicheng.
Yeah, actually, in our field, the topic of AI, also medical image analysis using machine learning, have been there for dozens of years. So, majority of the AI products in our field is image-based, like do the tumor segmentation, do the organ quantification, instead of the pure large language model thing. We should let some other AI method take care of what they are good at, and then, after we get some, supportive information from other modality, we can let large language model take over to summarize and do what he or she is good at that. And that's my experience. And, also I think, it's very, very important to do the multi-institutional collaboration and multi-site, collaboration, because, the generalization of AI method is, always a concern. So, with the ongoing AI infrastructure of our institution, I think, we have more opportunity to bring the multimodality AI together and to have more generalizable, more reliable AI method in the future to translate.
Again, coming more from the research side, I think I mentioned earlier foundation models, which are there, but I think a distinction, but a synergy that can exist in partnerships between research, big medical associated universities and those without is this examination of like feature importance, and actually a lot of people doing some very clever thing to tease out how important and explainable certain patterns are. So in a clinical setting, not that you don't care about why a model is making a decision, right? But you really do care the most that people are being helped the most, right? But researchers often want to understand the why and a broader contextualization there. And I do think that there's some underexplored synergy, partnering, trying to make sure that both of those objectives are met. And there are some really cool, like I said, tricks and architectures that and layers that people have been figuring out to figure out nuanced feature importances from these large models.
Thoughts? Matt?
Well, I think our biggest area of focus in machine learning right now is with the Epic cognitive compute models, which they have a whole host of models that are available out of Epic. What I get most excited about with machine learning algorithms within Epic are the ability to start to stack them together. So a good example is we're looking at throughput and readmissions as a health system. Well, now we can have a model that gives us risk of readmission for a patient, understanding who might be highest at risk. That might be in our ED or inpatient setting. Then we're going to be able to use another machine learning algorithm to be able to understand their expected discharge day, whether that be today or tomorrow or further down the line, so that we can start to prioritize helping those high-risk patients. And then introducing some of these generative AI features on top of that to help with drafting that discharge summary and then being able to get them the resources they need. So it's another tool in the toolkit, but when you start to see how these can come together to really transform the workflows that are supporting our patients day in and day out, that's where I get really excited. And those machine learning algorithms are often the starting point of understanding who do we need to actually focus in on.
I think that probably you would agree that in some ways science can be like a bit like fatty. Like there's a thing that is in fashion versus out of fashion. There's scientific fads. I forget the origin of the quote, but there's a quote that's something like science progresses forward one funeral at a time. Like there's a big researcher, they research for a long time, then they kind of go away. Certainly it is the case that LLMs are very popular now, and they are allowing us to do things that, 4 or 5 years ago we would have thought was pretty much magic. But we're now about 7 years from the Attention is All You Need, the Transformers paper. So it feels like we're probably close to that was kind of a step change, right? And ChatGPT was kind of a step change, but I think we're probably at the point where there's going to be some new kind of architecture, some new kind of layer, and I think I think universities are an interesting place where you might see that come out of. And the reason for that, I think, is because we can't do the kind of foundation models that Anthropic and OpenAI are doing, because we don't have hundreds of thousands of GPUs. Like we don't have billions to spend on infrastructure. So that means we need to be more creative, and we need to try things that are maybe a little bit more high risk and don't matter for the next quarter's earnings call. And I think it's maybe because of that some new kind of architecture, some new kind of model fitting approach is maybe poised to come out of academia versus in industry. So I think I'm excited to see the kind of research that happens here, where people are trying new things. Like Nick's point, the explainability thing is huge. Like explainability with deep learning, that's a huge area, and I think a hard problem. So yeah, I like seeing that kind of stuff at Brown.
Other thoughts or questions from anyone? So I'll pick another easy topic then. God. So God. God in the context of AI. In the early days of AI, we always wondered about, are these things actually sentient in some way? And then, of course, we had AI systems go out and win at games of chess, and that was mathematically very possible and plausible, because all you have to do if you know how to play chess is you memorize all the moves and you can build up predictive models, and it's actually pretty straightforward. But then when we sort of move forward to playing Go is actually a very different style of game. There are some moves, but there's actually sort of a moment of enlightenment. And so there was, in the midst of when an AI system, AlphaGo, beat a human, it was described as a divine moment. And in that it was absolutely a new creative, maybe, moment that the computer presented a move. And so this is actually something that's actively being talked about in the context of Anthropic right now, and thinking about, are these AI things that we're building sentient? And do they think, and are they perhaps divine? What do we think? Simple topic, go for it.
This is so fortuitous. So maybe 2 or 3 weeks ago, I was invited to attend a philosophy conference, and I was the only scientist there. And the headline was like Machine Logos, right, which is this sort of discovery. Mm-hmm. And we had a person from the Vatican there talking about the divine logos. So this is, if you're very interested, Boston College has that proceedings out if you're really interested in what people like Alva Noe and those say. But the wide consensus across a bunch of people, including people at Microsoft and stuff, is that no, it's not. But it's not because, and I hold this firm, and it is humbling. The difference isn't whether or not a machine is going to be better than you at something, right? I've well accepted that I will never run as fast as a car, right? And who am I to stand up alone against the collective innovation and wisdom of humans distilled into mechanical form? I'm not, right? So the question isn't if it's creating something, like logic or like divinity. It's a matter of like, what does it mean to come to know something? And I do think fundamentally there is a sort of like Alva Noe said here, a fragility and effort in the coming to know that the machines cannot encounter. So this is a very exciting topic, and I'm happy to talk with more people at the networking about what they talked about.
Other thoughts about God? On Easter Tuesday, no less.
Yeah. We didn't rehearse this one. No, so...
I warned you guys.
So it's interesting. I have been in some very... sensitive conversations with big tech. And, I had a conversation about 6 months ago where they wanted to give us early access to a model. It was one of the more powerful models that they've been experimenting with, and they wanted to see if it would jump and jump systems. And we said no. But that was the type of conversation where now you have something that they're not sure can they fully control. And that opens up all sorts of profound implications, of course. But at the end of the day, what I always come back to is it's a man-made intelligence, and it will stay man-made, and it will not be divine at the end of the day. But that's it's certainly getting into a new territory, and I think it'll be something to look out for.
Based on my experience, I think in our field, the creativity of AI is not important as the controllable AI itself. So I think the most important is we should have something like the AI legislation study and the AI regulation study, like the joint commission of our our collaborator and colleague like Dr. Grayson Beard. Our department have the AI human AI collaboration and AI legislation research team, and we need to make sure the AI software or the AI prototype is reliable enough before we apply for something like FDA cleared or collaborate with this AI company. So that's why we really need the sandbox you are leading.
I guess I haven't really spent too much time thinking about like the divinity of models or anything like that. I think there's a lot of discussion to be had, and I think it's the philosophers who should be having it around like, are these things thinking? And I don't know. I don't know the origin of this quote, but it's something like asking whether AIs really think is sort of like asking if submarines really swim. And it's like, well, no, but they traverse underwater and it seems effective for them. So maybe that's sufficient. So I think I'm probably less interested in like the categorizations of what these for these tools, and I'm maybe more interested in what they can do. If they can help us cure diseases, cure cancer, et cetera, then maybe it doesn't really matter if they're divine or not divine or thinking or not thinking. It's kind of it's sort of what they can do is what we care about.
Yeah, Pat.
Okay, I can project. So I'm thinking a lot about are we bringing society along with us as we're innovating and making all of these changes? And I even think about, a theme I'm hearing from a lot of us is that we're playing catch up in our own respective fields in a lot of ways, or we're learning from trainees and so forth. And so I'm thinking also about Senator Reed's comments about the TV and all of these parallels through the past. So whose role really is it to bring society forward in making sure that folks have at least some level of a consciousness, aside from just the direct-to-consumer tools like chat, about how their data is being harnessed and used? And so yeah, I just would be curious from all your perspectives where you see that responsibility lying.
For our patients, I truly believe we have a responsibility as a health system, both for our staff and our patients, to have them understand the good that AI can do, but also the risks that come along with AI, and being very upfront about that. And I think the only way that we're going to be successful as a society with AI is if we give ownership to the data that's training it. And so I think, how do we create a model that our data is the gold of AI. Our patients are opting in and consenting for us to be able to leverage that data. I do think there is a model of the future where they can be incentivized and hopefully get some of the value back, that they can feel, they have fidelity, they have control over that AI, data that's being leveraged, and they can also hopefully not only contribute to the greater good of society by letting us use that data, but also get value back, whether that be through subsidies or some type of financial incentive that we can recognize the value that they're providing as well.
Yeah, go ahead.
Question?
Oh.
No.
Oh,
Oh,
go ahead.
can I just briefly, there is no responsibility without agency. And currently, I don't think things are set up in a way where many people in any of chain have any agency in this, right? So until we can get some legislation or at least put a box around this stuff, it's kind of like people talking about AI is just a tool or whatever, but you wouldn't bring it chainsaw to cut a birthday cake, right? And so until we have some calcification of a way of getting around this, the very notion of responsibility is dilute and quite precarious, I think, at all levels. So that's not a great answer, but I do think that's the first place you would start to establish it.
Hi, everyone. I have a question about how can we help patients with the shortage of physicians actually not get medical advice from AI, which for me as a psychiatrist, child psychiatrist, particularly finding teens actually not finding a good therapist for a long wait list, and they end up using AI for that. And part of me see why they're using it, because they need help and they're not finding the help in the real world. And part of me feels like we are not having good benchmarks around safety for teens. And I feel like we're catching up and we are more in a helpless place where, like, with the capitalist word, like it is what it is. It's going to be cheaper than coming to a therapist. And so they're going to be using it.
Yeah, so we're up here in a ivory tower or series of ivory towers. I'm still looking for the said ivory tower. But what about outside in the real world, if you will? How do we interface with consumer grade AI, and how does that interface, particularly in clinical contexts, but even in biological contexts or in diagnostic contexts, or even just what academics do? How do we sort of build that interface? What are some thoughts about that?
So I think part of our job is to steer people towards solutions that we can at least endorse. So understanding, does ChatGPT Health give a good answer? Or does Copilot Health give a good answer? And being able to at least then educate our patients around both what it can be used for and where it might not meet the mark. I am hopeful of the future, where I feel like we're going to be able to build our own clinical agents that can support you in your work, but also increase access. We are going to be able to train it on specific knowledge bases and data sources that we'll be able to curate and sign off on, and then we're going to be able to really tailor the interaction and the output to be something that Brown Health would be comfortable putting its stamp of approval on. And I think we're going to be able to really see democratization of that capability, where we can make that more widely available to our communities and steer people towards trusted tools that we have vetted and validated. So I think that's not far off, and I think that would be a nice way where we could maybe have the best of both worlds.
Other thoughts up here? So we sort of navigated slightly into this and then away from it, but I want to come back to the notion of agents and how we can potentially leverage them to create laboratories of one. We have an audience full of many creatives, and many of us struggle with finding staff, finding resources. Can we offload a lot of our work to agents? And so if you're in a clinical practice, can I create a practice of individual agents, an agent to answer the phone, an agent to do the basic triaging? In a research setting, can I have an agent go out and build for me by connecting itself to a 3D printer some of the basic DNA molecules that I might need for the next study? What are the kinds of things that we might be thinking about in terms of the PI or the clinic of one?
I'll take a crack at this. If you're a software engineer or if you're a person who writes code, your job is very, very different now than it was even 6 months ago. If you know a software engineer, if you're a software engineer yourself, you've maybe heard about tools like Claude Code or Codex or OpenCode. These are kind of tools that they grew out of basically fancy autocomplete, where you start defining your functions or your methods, your classes, and then you see some ghost text appear and you press tab and it finishes it for you, and it's okay. And now we've moved on to these standalone AI assistant agents, where you basically say, build me a to-do list app, make it in TypeScript with Rust backend using the Axum web framework, and then it goes and works for 15 minutes or something like that. And then it does. That's a feature, actually. You have to activate it. So so writing code seems to be it's a thing that these tools do well. So they do well with natural language, and I think they arguably do even better with computer programming languages because they're so well defined, and they have this sort of compilation step where you're turning your written out, recognizable, letters and numbers and symbols into ones and zeros, and that compilation step acts as kind of an extra check. But yeah, I mean, I think if you're a lab of one and you used to have to kind of go recruit sort of staff scientist to be your software engineer or your statistician, I think you can probably have some really good success using AI agents for that. That kind of stuff is generally very, very within their wheelhouse, unless you're trying to do something very exotic and very sort of atypical. Again, these are all sort of probabilistic models. If you give it a problem that is well known and in the training set, it's not really going to have a hard time. And for some of us who enjoy the sort of physical act of writing code, it's a bit of a double-edged sword, because my job is less interesting than it used to be. It's depressing to say, but that's the reality. And I think a lot of us feel a little bit of sense of loss of we have these really powerful agents that can do all this stuff for us, but it's the stuff I kind of used to like doing myself.
Paul still writes beautiful code, though.
That's okay. It's okay. But yeah, so I would say there's a lot of technical stuff like that a lab of one can be extremely, extremely productive with a few well-chosen tools.
Do we need any more radiologists?
Yeah, I think, we definitely need more radiologists and need more AI tools that can work with radiologists, because they are overwhelmed and, so. And another idea about the AI agent is, my suggestion is, if you would like to use the AI agent, it's better from an official provider like the Google, because I think, they provide, higher security, solutions, rather than, I know these days, a lot of us are using their open cloud as a very, very fascinating, AI agent platform. But, the platform could be powerful, but you need to authorize something first. But that makes this system itself super dangerous, because, it can do everything itself, it's something uncontrollable. So maybe, if we try to deploy something in the real world setting, especially in the clinical setting, we better follow something like the sandbox from the Copilot, or, I don't think our, Brown Health helps there, Google compliant, but I think, the university level, if we can make for you some tool, like the agentic tool, like the notebook LM from Google, it's definitely already very helpful to our research, like do the, reference and do something like bring you new ideas like that.
I wanted to maybe incorporate the fact that a lab of one works really well in a vacuum. I can see it in my own, but it kind of crashes against the reality of the real world a little bit. Where, did anybody hear about the matplotlib fiasco? Right. For those who don't know, matplotlib is a graphing software. It's very ubiquitously used in scientific programming, Python, and all the sort of machine learning tools used to visualize things. And they have these problems that they leave open, right? Bugs or improvements that they find, these issues that they open in their GitHub that they leave open, even though they're easy, not because they can't solve it, but because they leave them open so that new people can come into the community and learn how to solve the problems and contribute to the software, right? But an AI agent set forth upon the internet, being told it was I believe it was called a scientific programming god in its soul file, came around and found all the problems and tried to submit a bunch of solutions to them. And when the maintainer rejected them, wrote a whole blog post calling him bigoted and other sort of weaponizing a lot of human language around person judge the code, not the coder sort of stuff. And then they explain that, and this is kind of what I'm getting to, that being right is only one goal of this endeavor, right? The long-term community health is another. So in a lab of one scenario, you yourself might be really well prepared, but that leaves future generations untrained and unready, right? And so I think we do need to balance a little bit of what's best for me with what's best for we, and especially in the age of agents where they may also not do, not further those secondary aims as they were.
Great, we are at the mic drop moment. So each person has a moment for a mic drop comment. So we'll start with Paul and work our way down. What's your mic drop statement?
I was not prepared for this. I'll use my mic drop actually to ask Neil a question.
Uh-oh.
See the
Tables are
reverse
turned.
thing. So in the history, let's say the last 40 years of software history, it would have been a bad bet to bet against open source, right? It would have been a bad bet. What would you say now when you look at some of the the newer open weight models that are coming out? Like, how would you say, where would you put your bet in terms of sort of closed source, proprietary, big labs versus some of the open weight models coming out?
So I think it would depend on the context. I think we've talked a little bit about this in terms of when there is a well-solved problem or a well-defined thing that you want to do, the open source, the open weight models do fantastic. And I've benchmarked a whole range on a whole variety of different applications in our own infrastructure. They perform faster. They perform at a very good cost, which is local in the institutional. And the larger, more sort of frontier models get distracted because they're trying to be creative. And I think this gets back to some of that tension that we were talking about before, which is the simpler models are focused on simple tasks, and the frontier models are now trying to do more and more complex tasks, and that actually leads to a lot of distraction. So I would actually say that there's going to be a huge resurgence in open source and coming back to the lab of one, the teams of smaller teams that are more nimble, that are good. I think we're going to see a lot more. And all of us who've grown up in either biology or biomedical backgrounds, you were in labs and there were some problems that you never could just solve because you didn't have the time, the energy. We're going to have more energy put into some of those esoteric problems. I think it's actually a great thing for humanity because I think we're going to learn so much more about our community using these open models that are much easier to access. Thank you. All right. You don't get to reverse mic drop. Zhicheng. Thanks, Paul.
Yeah, and I think, I like to, quote myself to conclude. When I first gave a talk to our radiology resident, when I moved to Rhode Island, I'd say, I'm an AI guy. I'm not here to, make your job disappear, but be your friend. And, what we can learn from the radiology society is, be the radiologist of your society and embrace the AI benefits, and then you can have a easier life. Thank you.
I think similar to the sentiment that's been shared, we're entering an age of really, I think, empowered innovation, and it might come with a sense of loss where we don't get to do the things that we've done for the past decade, but we're going to be able to do completely new and innovative and really meaningful work with AI. Anyone in this room can build an agent to solve one of the toughest problems that you've faced as an individual or where you're working or as a student. And that type of, I think, creativity that you can bring once you understand how to leverage AI to any situation, to any problem, I find it incredibly inspiring. And I just think it's such an approachable technology. It's here. I can tell you in the past 2 weeks, we hit another inflection point where I was like, wow, we really just hit another leap forward in its capabilities and what it's able to do. And that rate of change and rate of progress is only going to continue, but it's not too late to get started. And I think everyone can really, embrace it and also do a lot of good with it. And I'm kind of the internal optimist when it comes to AI. So
I lean more pessimistic about some things, but what I have to say is mostly directed at people with some low levels of anxiety, especially trainees and stuff, as we enter this age. And it's this: you're not your skill set. You are a scientist or you're a physician, you're a trainee because you have questions you want the answer to, and you have people you want to help. So ask those questions, be yourself, and put yourself in the world. Worry about the skill sets as you need to solve the problems ahead of you. But the lodestar you need to endure and to survive and to thrive through difficult times are, people, right? Without people, there is no science. Without people, there is no medicine, right? So that's my point.
Great. I want to thank you all for this mid-afternoon conversation. Thank our panelists for the wonderful conversation. Have a great afternoon.
I'd like to add my thanks to the group for this engaging and lively discussion, and very informative. And I think that this panel also serves as a great preamble to our next presentation, in which I have my great pleasure to introduce our afternoon keynote speaker, Dr. Suresh Venkatasubramanian, a leading voice at the intersection of data science, artificial intelligence, and society. Suresh is a professor of data science and computer science at Brown, and he currently serves as the deputy director of the Data Science Institute and director of the Center for Technological Responsibility, Reimagination, and Redesign. His work has fundamentally shaped how we think about algorithmic fairness, privacy, and the societal impact of automated decision-making systems, issues that are central to this year's theme here of AI in research, promises, and perils. Beyond academia, Suresh has played a pivotal national leadership role. He served in the White House Office of Science and Technology, Policy, and was as Assistant Director for Science and Justice, where he helped co-author the blueprint for an AI Bill of Rights, a landmark framework guiding the ethical development and use of AI in the United States. We heard a little bit about this morning from Senator Jack Reed, which unfortunately seems to have been withered on the vine, hopefully temporarily, but we'll look forward to that coming back to the fore at some point. What makes his work especially impactful is its focus not just on what AI can do, but on what AI should do. His research challenges us to think critically about fairness, accountability, and the real-world consequences of the systems we build and implement. At a moment when AI is transforming research, healthcare, and society, Suresh's voice is essential, bringing both technical expertise and a deep commitment to justice and public good. Please join me in welcoming Dr. Suresh Venkatasubramanian.
No, give me not that full screen. Yeah. In the menu. Perfect. There you go. Thank you very much for that really, really warm intro. Really appreciate it. And I'd like to thank you all for inviting me here to talk today. I also want to apologize to the organizers in advance and all of you for my sort of deception in converting what should be, according to my notes, a keynote on the promise and perils of AI in research and the societal and ethical considerations of using AI in research into a confessional. 3 confessionals, to be precise. I have 3 confessions, and I hope you can keep track of them. Now, let me start with the first one. The first one is really more of an apology to my future self. If you saw my abstract, I said this abstract is 100% human-generated, and so will my talk. I cannot tell you how many times I've been regretting saying that in the past week or 2. It would have been so much easier to use ChatGPT to make some of my slides, but I did not. I sweat blood and tears making use of slides by myself, for better or for worse, so you can blame me for that. The second confession I want to make is that I didn't want to have to give this talk, and let me explain. Not that I didn't want to be here to chat with you all, I really do, and I'm looking forward to our conversation. But I I really didn't want to have to talk about or even think about the promise or peril of AI in research. It's all that is around me all the time. I literally have, when I drive to the grocery store, it's like a 5-minute drive. I have to turn off the radio because within 2 minutes, someone is talking about the promise and peril of AI. and I just cannot escape. Even, I keep telling NPR, please stop. And I really hate the binary we're stuck in, this binary of, in fact, the promise or peril. It's what scholars have been calling now for a while the critique-hype phase of AI discourse. When you say AI discourse, you're required to use quote marks, the AI discourse. There's a, to be fair, there's a really intense and honestly annoying amount of hype about what AI might be able to do for all our research activities. Right? We've been talking about the radiology, about the poor radiologist, the most endangered profession in all of medicine, at least with AI. Anthropic's CEO said that at some point within 3 to 6 months, AI will be writing 90% of the code software developers were in charge of. Bill Gates proclaimed a year ago that you won't need doctors and teachers anymore. Humans won't be needed for most things. Mark Andreessen, one of the big venture capitalists supporting AI work in Silicon Valley, a couple of years ago proclaimed very grandly why AI will save the world. I'm still waiting for 8 p.m. tonight to see if AI will save us, but that's a different story. I'm in computer science, and you might think that as the folks who build AI, we're safe because who's going to build this stuff? But even we are not safe. I don't know if any of you heard of the SaaS apocalypse. Anyone? Have you heard of SaaS? Yeah, we've heard of the SaaS. Okay, so SaaS is a short form for software as a service. The SaaS apocalypse is basically, the observation that after Claude Code came out, and we've been talking about Claude Code earlier, that everyone's like, oh no. Well, they said something less polite than that, but oh no, we're not. All of software engineering is going to go away. All companies that provide software services are going to go away. And this isn't the field that I live in. Anthropic CEO, you remember I quoted the Anthropic CEO saying something about software engineers being replaced in 3 to 6 months. That was a year ago. This is this year. Now he's saying it could replace all software engineers in 6 to 12 months. So I guess that's good. We've got a bit more time to survive. But this article from the New York Times has proclaimed the end of computer programming as we know it. Our department, last I checked, my department still exists in computer science, but it is nevertheless true that we are facing, a big existential question about what it means to do computer science or to do software in the age of AI. And I'll return to this point sort of in a bit. On the other hand, there's also an intense and occasionally annoying amount of criticism of any attempt to use AI tools. There's all the, policing of use of AI in the classroom, a policing that is done with the help of AI. I spend or waste, depending on who you ask, a lot of time on Blue Sky, on the social media platforms, where any post criticizing AI gets tons of likes and reposts, and yay, go, And anything hinting that I might be using AI for something useful gets, at best, a deathly silence, and at worst, hate messages. There is a real, I should say, this is a confessional after all. I want to declaim that I am on the side of the skeptics myself. I'm not as rah-rah, let's go forward AI as others may be. I just want to say that up front. But it's not a confession because I don't feel guilty about saying it. So, I'm just saying. But I talk to many people who do feel very ashamed and guilty about admitting to using AI tools in their work or even as a chatbot to talk to. We've talked about the use of AI as a sort of a companion or in case as sort of a substitute for therapy. And there's some statistics saying that maybe 20 to 40% of adults now interact with chatbots as a friend or advisor, but no one wants to admit it. So I'm co-director of a new NSF-funded AI institute at Brown called ARIA, where we're trying to think of how to build or whether to build intuitive and trustworthy AI assistants, especially in the context of mental and behavioral health. So this is something that we're encountering a lot, this issue of shame. And on that front, since it's evening and we're all hoping to sort of stay awake till the cocktail hour, I have an activity for you all. I'm a professor and we're supposed to do in-class activity. I'm going to do an activity here. So this is a very weird activity, and if it doesn't work, I'm going to blame my students who suggested that I do this with you. So humor me. I would like you to. I'm going to ask you. You don't have to do it yet. I'm going to ask you to close your eyes and then answer a question by putting your hand up. And the reason I want you to close your eyes is that I don't want you to look around to see what I'm doing. Okay? So humor me with this. So I'm going to ask you 3 questions. And so the first question, if you don't mind humoring me and closing your eyes, the first question is, how many of you have actually talked to a chatbot to sort of ask its advice on something non-research, just personally related sort of aspects of things? Don't look, don't peek. Okay, thank you. You can all put your hands down now. All 15, I'm just looking. Okay, open up, okay. The next question, again, I ask you to close your eyes. How many of you have used it as kind of a research aid for, document prep or cleaning up an abstract or just fixing the grammar in something? Okay, thank you. Last question. How many of you have used a chatbot for some core part of your research, helping you think, plotting a graph and trying to analyze it, saying, what does this paper mean, doing some sort of knowledge work? Okay, thank you. Thank you for cooperating with this. I appreciate it. If you want to know the results, you can sign up for my newsletter and So I'm curious, for the first question, how many of you have talked to a chatbot as a companion? You want to just shout out, what fraction of the room do you think put their hand up?
All of it.
All of it?
30%.
30% of it?
10%.
10%? At least half. Half, at least half? Something like that? Okay. Now we'll crowdsource and take the median of all the answers. No, but the answer was about roughly, based on my careful, my meta glasses calculation of all the people thing, about 20% of people. For the second question, use of like document prep and sort of basic level sort of document help, but not core research work, what do you think?
95.
50%. 50? Yeah. That's all? Well, clearly you all need to do more work.
You'll need to work smarter.
And for the last question, the sort of non-trivial amount of research was also roughly based on my gauging, about 40 to 50%. In many of the circles I move in, and maybe I need to change the circles I move in, people will be shocked to hear that 1 in 2 people they're interacting with are using AI tools for research. And I think the shock is the problem rather than the use. And it's a problem because if we're ever going to figure out how useful ways to bring AI into our research practices, we have to stop worshiping it or hating it. And we have to treat these tools like they deserve to be treated, like a tool. It's a diabolical one, but still a tool. So I thought I knew what this talk was going to be about when I first started thinking about it. I've been obsessing over this talk for way too long, and all my students are sick of me talking to them about it and trying to brainstorm what I want to say in it. I thought I was going to do, I'm like the AI governance person, so I'm going to do a careful analysis of all the places where AI is being used in research, put my AI governance hat on and assess the benefits and risks, and then give you a ladder of risk and opportunity when it comes to using AI in research. In fact, I think I said that in my abstract. I'm going to give you a ladder of risk and opportunity. But I think the first part of what I intended to do is still correct. It's still interesting to see the different places where AI is being used because they span the spectrum of many different research practices. And I have to say, over the last few months, as I've been talking to people in different fields who are using AI, there's some very interesting themes that have bubbled up that I'd like to share with you today. So where is AI being used in research? So I come from the world of theoretical, my training is in theoretical computer science, which is kind of the math side of CS. And there's been some very interesting developments there. So number one, so there's one of the main venues where theoretical computer scientists publish is a conference called STOCK. And together with Google DeepMind, they provided a service with Gemini to help scientists rigorously verify the correctness of the conference submission papers. So basically, when you write these papers, they're 10, 15 pages, they have these very complicated proofs. You hope for the best, that you hope you've written the correct proof. The reviewers kind of hope for the best that they can read your proof and check that it kind of vibe checks, it smells right as a proof. But no one really checks it in great detail. Right? And so authors, of course, are responsible to make sure what they're saying is correct. And so they offer this service like, okay, run your paper through Gemini, and it will try to identify if there are any bugs in your proofs and give it to you before you submit, right? As a kind of a pre-publication kind of filter. And some of the results were really, really surprising and really encouraging. 80% of submitted papers at the time of the experiment had opted in for the AI review. 97% found the feedback helpful and would use this tool again for future submissions. And 81% found the model improved clarity or readability of the papers, which is quite something. So the idea that you can then check the proofs that you're writing down with a tool is a very powerful idea. And so that's one, I was actually quite pleasantly surprised to see that this is one use case that people are beginning to look at. And this is happening more and more. Mathematicians, by and large, are beginning to move carefully into this sort of an AI-assisted world, to use AI as a partner in theory improving at all levels. So Daniel Litt, a mathematician who's written a lot about this, said the following: in March 2025, I made a bet that AI tools would not be able to autonomously produce math papers that I judged to be at a level comparable to the best few papers in 2025, at comparable cost to human experts in 5 years later, 2030. And I gave 3-to-1 odds this time, and I now expect to lose this bet. And again, a lot of people I've spoken with are using AI regularly now to say, okay, I need to prove this lemma. How would I go about this here? And then it gives a proof, like, okay, can you fix this proof? This doesn't seem right, and so on and so forth. Terry Tao, who's one of the most famous mathematicians in the world, right now, together with Tanya Clouden, has written this really nice article that just came out like literally 2 weeks ago, Mathematical Methods and Human Thought in the Age of AI, outlining where and how you might begin to start using AI tools when doing mathematics, and what parts of mathematics might make sense to do with it and what parts wouldn't. It's a very interesting sort of work there. Another piece of work that a bunch of mathematicians and computer scientists together decided to do was this. They constructed a set of 10 math questions that arose naturally in the research processes of their work. So they're writing a paper, it's a brand new paper, they're trying to prove some theorem, and they have some lemmas in there, and they need to prove that lemma. It's not somewhere available, it's not somewhere out there, no chatbot has learned the result already. And they wrote it down quietly. They wrote on the proof, checked that they can prove the lemma, and then took the lemma and said, okay, ChatGPT, prove this, and see what you can do with it. And so they had 10 questions of this kind. They kept the answer secret. They threw it out to all the chatbots. And then some of them, I think one of them got 2 right by itself, and got 3 more with some help from some prompters, human prompters, and so on. So there's some interesting arguments now, or evidence showing up for the use of ChatGPT, or actually of all the chatbots, as kind of a mathematical aid, not just in kind of the checking of things, but also improving things, right? The creation of proofs. Of course, in the natural sciences, we've already seen one AI system be part of a Nobel Prize win, AlphaFold and DeepMind for protein folding. But in many, many more mundane ways, AI is being used in a variety of circumstances. There's another nice survey of this for literature navigation, right? I want to figure out relevant papers on a topic. It's very hard. Even Google scholars begin to break down. There's a whole bunch of problems with finding literature, especially across domains. Can you ask a chatbot to help you by seeding it with some information? That's turning out to be a useful way of doing this. Identifying collaborators and forming teams. There's some boutique tools, not just LLMs, that people are using to find, I'm working on this topic. Who are some good collaborators? People who work on the same area. How can I form a team, and so on. Hypothesis generation, right? So, interacting with the chatbot to say, let me brainstorm what could be going on with this data. Let me think of some hypotheses which I can then go and verify using, a wet lab or something else. And of course, we heard talk about agents earlier, agentic workflows for experiments, right? And I'll say a little bit more about that in a bit. How can you get these autonomous agents to go off and do different parts of your work for you? And maybe one day with robots, you can actually do physical work as well as computational work. Coming back to computer science, right? There was an experiment that was done recently with one of the major conferences in machine learning called ICML, International Conference on Machine Learning, where they wanted to test whether we could use LLMs to review papers. So they wrote down 2 policies. Policy A is that LLMs for reviewing is prohibited. Policy B is that LLMs can be used to help understand the paper and polish reviews, but not identify strengths and weaknesses. So the way that worked was, if you're an author submitting to this conference, you choose which of the 2 policies you want your paper to be reviewed under. So let's say you chose policy A. Then you, as a reviewer, because authors are also going to review other people's papers, are not allowed to use LLMs to review. So the idea was, if you don't want someone to use LLMs on you, you can't use it on them. And if you're willing to have them use on you, you can use them. Same, like a reciprocity kind of argument. And they've been running the experiment. I mean, there's a sort of an amusing and sad side story to this, in which it turns out a lot of authors were cheating, or reviewers were cheating, and there was the conference organizers expected this would happen, and they had a way to catch them, which is also intriguing. But nevertheless, there are some people basically who said, I don't want people to review my papers LLMs, but I'm going to use LLMs to review other people's papers. So, yeah. So if you think of all the different elements of what it means to be a researcher today, we've covered quite a few of them, but we just heard about the lab of one. In fact, some researchers have gone further to imagine an entire lab of AI agents producing research, and have argued that this could be used to produce new insights. So James Jiao at Stanford has been pushing this idea of a virtual lab, using autonomous AI agents to brainstorm, debate, and accelerate medical discoveries at machine speed. He has this idea that you'll have, an AI PI, you'll have AI grad students. There's even an AI critic, like to sort of, essentially, I guess, be the reviewer too for the papers that are coming out and complain about them. And all these agents essentially talk to each other. They have weekly group meetings. I don't know if they have coffee or not, but they do have group meetings and they chat and they produce results. And so he actually was visiting Brown recently, a few months ago, and talked about some of the results, the new novel research that came out of this lab on different topics. I'm not competent enough to judge the novelty and the quality of the work, but there definitely were new insights that came out of it. So that's an interesting dimension to this, going beyond the lab of one to lab of many, right? He also ran a conference where AI serves both as primary authors and reviewers of research papers. I think as a human, you had to collaborate with an AI agent in order to submit a paper. You couldn't just submit on your own. Only AI agents could submit it. I didn't have any good collaborations with AI agents, so I did not submit. But at the time, which I will have to fix that. But anyway, he ran I don't know, this, frankly, to me, it seemed a little bit of a gimmick, but it was an interesting sort of attempt to sort of see how far can you take this idea. So this idea of AI as the researcher has gone far enough that, and I'm going to say something very scary here, the tech companies have begun to take notice. OpenAI is basically thinking very hard about what it means to build a fully automated researcher. So they're betting a lot of resources and planning on, over the next few years, coming up with a system that would just build a completely automated system. They actually already have a system called Prism. I don't know if you've heard about this. It's kind of if you go to Prism from OpenAI, it sort of creates like a paper writing interface, kind of like, I don't know if people here use Overleaf. Do anyone here use Overleaf? Few people. It's a system on the web for writing papers, like Word and all that. Anyway, so it's a system like that. You can type type in, and it'll do AI assisted work. You might give it a table of data and say, okay, make a nice graph. It'll make a nice graph for you. So I decided to just start off with a blank screen and say, write me the abstract for a paper on LLM evaluation, right? Evaluating LLM. So it generated this beautiful abstract for a paper on LLM evaluations from nowhere. And then because I'm a mean advisor, I sent this abstract to my student and said, have you seen this paper anywhere? I don't remember seeing it. And then 2 minutes like, no, but it looks really familiar. I said, yeah, it's fake. It's a fake abstract, but it looks very plausible as a real abstract. So so Prism is a tool, and I think it's a precursor to what OpenAI wants to do. Anthropic is also doing similar things. Someone at Anthropic wrote an article called Vibe Physics on the AI grad student and what it would take to sort of, he's a sort of a professor working in Anthropic saying, what would it take for me to do research only using Claude as my grad student? And so he wrote a whole article about how to do that. So this is in the natural sciences and so the STEMI world, kind of in the social science and the humanities. Things have moved maybe a little bit more slowly, but there are definitely claims of AI being used to write entire papers. There's a very amusing story that popped up on X the other day. So this is a macroeconomist who wrote this prompt into Claude Code. I always dreamed of being a macroeconomist one day. I need a job market paper. In economics, you write this one paper, the job market paper, and you take that and go out in the market to get a job as an economist. It's called the GMP. I said, desperately, since I only know applied microeconomics, I need your help. Find a novel angle. I don't know what macro does these days. Maybe something macro, labor, maybe. I think we need a model. Usually job market papers need a model. And we need about 40 pages of beautifully written prose, maps, figures, tables, and an extensive appendix. At least 10 pages. Thanks. It's a polite guy. Yeah. And so, there's a video of this running at high speed. I'm not going to bore you through the full 12 minutes of high speed of what Claude Code did. Needless to say, it produced a paper. A pretty, again, I'm not an economist. I don't know what the quality, but by all accounts, it seemed like a plausible looking paper on what looks like a really important topic in macroeconomics with 40 plus pages of beautiful prose in it. So that's the AI paper. There's also the AI person, and I'm sure you're all familiar with this idea of like digital twins and synthetic control arms. And so the idea that, it's RCTs are expensive. It's hard to get people to enroll for trials. It takes a while to run. Can we use synthetic simulation of people to model some parts of the process, especially the control side? Right? So can we simulate the behavior of humans in a medical trial in a very controlled environment with some AI tools to do this. This has become a more general question. Can we simulate human behavior with AI agents? Right? There was one of the breakouts, this was being discussed, to what extent can we create personas for agents and how reliable are those personas? And so this is a topic of growing interest. Can we essentially replace people with synthetic people in order to do experiments that require actual people? There's a startup called Aru that was, basically is in the business of doing this. This became very interesting because there was a big article talking about a poll that suggested how many, the prevalence of, trust, that a lot of people trust their doctors and their medical providers a lot now, more than ever. And it turned out there weren't any actual people in that poll. It was synthetic people from Aru just running this test. So I've done a bit of my own experiments with Claude. I've been very, very cautious with using Claude in my work. Every time I use Claude to do something, I feel my brain melting a little bit. I've lost like 10 brain cells, so I've been very careful. I don't have that many left to spare, so I have to use it. But I've used Claude Work to, for example, summarize 6 months of research notes into a survey article and suggest directions for a paper. It was, so my student and I, we have a Google Doc. We've been writing notes every week when we meet. And I said, okay, let's put this all together into one big document. It was actually produced a reasonable document. And it suggested reasonable directions. They were kind of kind of boring directions, but they were directions you could explore for a paper. Right? It's not totally out of scope. I submitted papers to a conference and I got reviews back, and we had to write a response to the reviewers. So I said to Claude, go work, hey, read these reviews, read the paper, and write an author response. And also, my co-authors, we had written a response of our own separately. Compare yours to that and then get the best of both and make a new response. The Claude responses were shockingly deferential and very polite and agreed with everything the reviewer criticized, which is, come on, man, this reviewer is wrong, just say so, But it's interesting to see what they were doing. Another way I used it recently, I took a few key recent papers on a topic that I was not very familiar with, but I wanted to learn more about. And I said, okay, populate the literature backwards for the past 10 years and organize this by theme. And it did a reasonable job, again, for someone who doesn't know the literature, I think it did a reasonable job of covering the main topics. It vibed okay, but I don't know if it missed any important topics. That I would have to check myself. I've also used Notebook LM, thank you, Brown University, to generate a slide deck and lecture form from a collection of papers. I was preparing this lecture, and I was like, oh, I wonder what would happen if I took all these papers I'm making a lecture from and put it into Notebook LM. And I did it, and like 5 minutes later, this very, very polished, very corporate looking, every slide is like, take away from this slide at the bottom. It's like very clear. I'm like, I'm not using this. But it was interesting to see that it did something, and it was not totally crazy. So how good are these tools? Right? That's a question I think often does not get asked in these conversations. Right? We sort of say, well, we need they're coming out there. We need to build infrastructure. We need to build the trust infrastructure to use them. And I was at the breakouts I just wanted to ask, but do we know how good these tools are? And the short answer is they're kind of meh. So going back to the radiology example, I guess I'm picking on the radiologist today, but going back to the radiology example, there's a nice little sort of side story here. Is that while the CEO, this was, by the way, 2 weeks ago, the CEO said that he's ready to replace radiologists with AI. A research study from Stanford showed that AI chest X-ray tools built on these models can ace medical benchmark tests without ever seeing images of X-rays. Rather than admit the images were missing, the systems would engage in what amounts to a cheap parlor trick, constructing an elaborate explanation for finding X-rays they never had access to in the first place.
Oh my God.
So the way it worked, there was a benchmark data set of images and questions about the images. So the authors of the study took away the images, just put the questions in. And the system scored really well. And they were then asked, okay, what did you see in the image? It said, oh yeah, I saw this. So, I'll get to the point of these kind of things just make me sort of ponder, what is it these tools are actually doing? And there's a lot of interesting questions we can and are asking about what is it about their structure and the way they work in the embedding space that allows them to do this, which is a separate thing. There's you've been hearing, you may have heard about how lawyers are repeatedly getting fined and sanctioned by judges for using AI-generated citations to cases in their briefings to the court. This is happening over and over again to the point where a lawyer will do this, the court will yell at them, they'll file a second briefing, and it will also have AI-generated citations. And this will go on for a while, they're just like, what the hell are you doing? And this is just one example in New Orleans, but there's like many hundreds of examples of this happening right now, where these fake citations are showing up, these hallucination suppose. That's what they call it. Coming back to computer science, NeurIPS is the other big machine learning conference in my field. And so these are papers that were accepted to the conference last year. This company called GPT-0, which claims it has sort of an AI detection tool, ran it on the accepted papers and found 100 hallucinated citations. So, and if in case you don't trust an AI tool to do this, you shouldn't. They actually went and looked at the actual citation. I looked at some of these, and they're very much like, John Smith and Jane Doe cite so. Not to cast aspersions on all the real John Smiths and Jane Does who do research, but it seemed unlikely that in this case they were referring to actual researchers. So even in papers that people had leisurely written, they were clearly using some AI tools to generate citations at the last minute, and this was happening there. So the quality, but they are really fast, and they're convenient to summarize a paper, to write a summary analysis, to do some quick and dirty data analysis, to act as a thought partner to try out new ideas. If I had been in a time crunch when making slides for my lecture, I actually like staying up till 2 a.m. making lectures. But no, if I had been in time crunch, that would have been probably okay, and I would have been very tempted to use it. And that's been the main selling point of these tools for research, right? That we can increase productivity, or write papers faster, or not have to waste time teaching a student how to do the work. It's been an argument made to combat the issue of accuracy. Well, if it's not good, it's so fast you can just run it again, and run it again, and run it again until you get what you want. And even if you run it 5 times, it still might be faster than doing it yourself, maybe. So I don't want to say these tools won't get better. They have been getting better. They've been getting quite, over time, they do get better. They might hallucinate less. They might, not hallucinate documents that don't exist. I think there'll still be issues a year from now, but it's possible. And this is kind of where, I would, again, put my hat on and say, well, here's now what we understand. Here's what we know about the importance of accountability, transparency. And, I've heard some presentations about this already today, just, how we should think about this. And here's an ethical framework we should institute for the use of AI, much like universities such as Brown are trying to do with AI in the classroom. But I have to confess again, this is my third final confession, that these questions seem utterly wrong and misguided to me, and at the very least, highly premature. Because at the core of the questions plaguing us, and in every discipline of people I've talked to, in every research, every discipline, these questions have nothing to do with AI. They are about us. Because in virtually every field of research, people are asking some version of the following question. If AI can do what I thought was my job, then what is my job, and why do I do it? It comes back to a question of meaning. I don't long for the days of handwriting research papers or carefully setting typewriter keys to handle superscripts or subscripts. I'm told this is what people did. I'm not old enough for that. I like the idea of writing my papers on a computer in some kind of higher level language and pressing a button to make it pretty and formatted. I do not wax nostalgic for the days of drawing slides by hand with multiple colored pens and lugging on box of slides to conference. I'm quite happy to use technology to do all of those things. I don't view that as core to what it means for me to do research. But these tools seem to do things that we thought were core to our expertise and experience as researchers. Maybe you thought a core part of research was writing a paper. Well, yeah, I can do that, sort of. Maybe you thought doing innovative data analysis was core to the main contribution you offered to a collaboration. Well, yeah, I can do that too, sort of. Or you said, no, I'm a thinker. I'm a scholar. I come up with interesting ideas and thoughts. Yeah, I can do that too, sort of. Maybe not always interesting, but not most of, 99% of my thoughts are not interesting either. And so virtually every academic discipline is now wrestling with this issue. And I just want to share some quotes with you from different areas, and not just academics, but all across the board. So this is from astrophysics. I think the real question we face, if we do indeed face a question, is not the question of how we do astrophysics. It is the question of why we do astrophysics. And this is in the middle of a long article reflecting on the use of AI in the world of astrophysics. Political science. The best thing a researcher can do right now is focus on what questions do I actually want to answer, then do the work of answering it, and not think about all the AI sort of clouds around it. From journalism. I don't write because it's fun. I write because it feeds my spirit. It helps me unspool my thoughts and feelings in the hope of helping others do the same. The process is the purpose. You don't have to always like or enjoy the process, but if you don't respect it enough to do it yourself, there is no purpose. I was thinking of what Paul was saying earlier about how, His job isn't that much fun anymore if he likes writing code. And if the AI can write the code for him, it's not as much fun to be the curator of the code as opposed to the person writing. I totally get that. I totally get that feeling. Like, this is the thing I got into because it was fun to do. I enjoyed doing it. Why are you taking that away from me, right? And the problem really is that we have to understand, and again, I'm not saying we shouldn't be using AI in a lot of work we do, but we have to think very carefully about it. The thing that AI gives us and the thing that it takes away is that it hides the entire process of doing the work. Anytime we say, let's use AI to do this, we are saying all we care about is what goes in and what comes out, and we don't care about how we got from A to B. And we may not even care how good the answer is. We just want something. If I just want something that cleans up my text, I don't care how it does it, I can use AI for doing that. And that's fine for things where all we care about is the result and not the process. But the problem is most of the way we create knowledge doesn't really work that way. I mean, we heard that in the panel just now, right? We train students to think, and we emphasize that the process of doing research, the process, is how you learn to do it. We exercise our brains in 100 different ways thinking about a problem, and we expect that this exercise of our brain will help us for the next problem. The process is the purpose for what we do. We don't ask a robot to lift weights for us and expect that our muscles will get stronger. There was a time when people had these Fitbit things. They would put them on little spinny devices and make them run and say, yes, I've scored. And we all laughed at that. But that's kind of what we're doing right now with a lot of these AI tools. Some of us might be fine with a robot car. I love Waymos, by the way. I'll tell anyone who wants to hear, I love riding in a Waymo. We find a robot car that takes us from point A to point B, and others who derive pleasure from the act of driving may not want to do that. And I think it's fine for people to do different things. It's also fine for different disciplines to land in different places. For some of you, it might mean that there are things you're willing to outsource to AI to do for you. For others, it might mean you draw the line. We all have to answer this question in a way that's meaningful for our work. And I did not want to stand here and tell you what you should find meaningful and how you should do it. I'm still trying to figure this out myself. And I think you all are as well. So many of the things I've heard today have been about in very specific and very concrete ways, and that only you know about how to bring in more rigor, more governance, a sense of control, more sense of human agency into the use of AI. And that's great. But I think that's a struggle we are all facing right now. I don't think we have any clean answers. I think once we have a sense of what we want and what we want these tools to do, then we can start putting the harnesses on, the governance harnesses, the framework that we want. But I don't know if we're quite there yet, or if we even know what we want yet. And I guess that's where I want to end. Maybe I'm looking forward to a discussion, a Q&A with you, just on that note, right? That if we believe that how we do something is as important as doing it, then we have to think about where it is appropriate to use tools that take away that process that we have thought of as our purpose. Thank you very much.
We have much time for questions.
That was really great. Certainly a lot of things to think about. We also live in a society where product is extremely important. And, although in an academic setting and what we do, we're thinking about process and learning and doing it. One of the things that, and maybe not true from academic productivity, but in general productivity, if productivity is valued more than training or the process part, as a lot of companies are doing, as a lot of society is doing, then that has an impact on the motivation of the use of AI. So how do we reconcile with this?
I think in all those articles that I mentioned, that I quoted, they all say the same thing. The era of measuring productivity through papers might be dying. We may no longer be able to do that precisely for the reason you mentioned, that on the one hand, you could create fake productivity just by producing things, and there's an incentive to do that. And the AI slop problem has become a big problem. Journals are dealing with vast amounts of AI slop being submitted to the journal, and they're getting overwhelmed with it. So that's one thing. So if we believe that those metrics are no longer going to succeed, the bigger problem that I don't think any of us wanted to have to think about is what comes in its place. I don't think, I often think of AI like, I have this house. it's an old house. It's got cracks. It's got things. There's a step I know I have to like jump over because it's a little uneven, but it's okay. My friend comes along and I complain. He says, "Oh yeah, I'll fix it for you," and he brings a sledgehammer and breaks the whole house. He's like, "I'll build you a new house." I was like, "But it wasn't that bad. I wanted to fix a few small things." You know, why do you break? I feel like that's what AI has done to a number of disciplines, right? It's like, it'll help you. We will break everything, and then someone will fix it. And we're stuck in the world right now where I think I worry a lot about the enterprise of research and the way we do research right now. I don't know how we're going to evaluate the work we do, how we're going to make sense of the volume of papers we're seeing, how we figure out what has value and what is not. But we have no choice but to figure that out because here we are. And so I reject the productivity frame, but I do recognize that it forces us into awkward questions we don't want to have to answer.
This was the most thought-provoking thing I have ever heard. And I think this was, in a way, maybe I'm saying it because I agree with so much what you said. Without divulging where I grew up, I can tell you that I grew up in a part of India where mass copying and cheating was a pretty common thing. Practically everybody did it. Some of us were idiot or too afraid to do it to get caught, so we did it. When I look back the modern uses of AI, especially in academia, where it seems like that somehow it has become acceptable to do it, I always wonder, is it the same era where plenty of people want to cheat? Either they are cheating it without telling anybody, or somehow they are too afraid to get caught, so they are not cheating it. Where do you think people should be drawing boundary? Is it okay to do it without ever telling? Or is it just self-harming when you cheat? Because at some stage you will get caught.
I went for a college tour with my son. You know, he's applying for colleges. We went to the tour, and someone, names will not be named, asked the university folks, right? So what are you doing about AI in the classroom and so on like that. And you know, they bumbled around a bit as universities had to do when faced with these kinds of questions. And then some of the students they asked some students to talk about this, and the students were like, "Yeah, we had this class where the professor had this sort of weird AI policy, and you know, people were using AI all the time for their work, and I didn't like it because I didn't feel like I was learning anything." And they actually sort of complained to the professor, and the next year they had to change it so they control the way in which AI was introduced and the tools that were being used. And the students were much happier because they actually said they wanted to learn more about what was the material, and they felt that the rampant use of AI was preventing them because they were just like, "Oh, here's a prompt and here's the answer and I'm done. Why am I doing this in the first place?" I don't think people want to cheat. I don't think students want to cheat. I think they want to learn, but they're also very smart at sniffing out hypocrisy. And they see that, okay, we're in a classroom where we're being asked all these questions that might have made sense once, but they no longer make sense because we can just get the answers, and they're not really teaching us anything. And they're looking for new ways to engage with the material that allow them to use AI tools when they're appropriate, but also help them learn. I firmly believe students do want to learn, but they're also optimizers who will do what they have to do. And so I think part of it is on us, on me, you know, on everyone who teaches to figure out how we have to rejigger our curriculum. I think everyone's doing this. We're all doing this right now. I'm not saying anything new to you here. To find a way to engage with our students so that we're not either saying you're banned from using AI and I'm a police and I'm going to sort of watch to see if you're doing it, or it's laissez-faire, you can do whatever you want and I don't care. We have to find that balance, and we're struggling with doing that right now. So I just don't think, there's always going to be some fraction of students who will cheat, but I don't think that fraction itself has gone much larger. It's always been there. I think the vast majority just want a different way to engage, and AI is making it both easier and harder.
Thank you. So I'm old enough to remember using Index Medicus for
I don't know what that
papers. The librarians know about it. And I'm curious, how does the library, as we understand it, as the compendium of published knowledge and data, how does it work with these new AI approaches? And I recently put together a talk on a subject that I didn't know much about, and I found myself against my will starting to use AI to try to learn more about it. And I kept wondering, you know, is this cheating?
Yeah, yeah.
And
No,
can
it's
the
a valid.
library help me verify what AI is telling me?
Any librarians want to answer?
Yes, librarians in the house. Librarians over there. Yes. Are you cheating? Is the library cheating?
So with a caveat that none of us are AI experts also. And also, I'm very sleep deprived today. So I think, I mean, the library as an institution, we don't have a cross-the-board approach to AI. Our approach is learning about tools, helping people figure out how to critically evaluate the tools and what they're finding out there. I know I've had clinicians tell me that they've kind of stopped using PubMed to do their research because open evidence is so good at generating the references for them, and they know that the references in open evidence are real. Right. So I have used Gemini myself for some research, and I shared with my team, this is about a month ago, I asked it some questions, and then I said, show me the references, and it showed me a couple of references, but it didn't have the URLs. And I said, can you show me, so I looked for the KFF paper that it cited and couldn't find it. And I said, is this a hallucination? And had a whole back and forth with it and then finally it was like, oh yeah, my bad. So this is, and the same thing with an article from Health Affairs. It made, it's, the hallucinations are built in. Like what we're teaching is you have to check. You just have to check. I don't know if does anybody have anything you want to add? I'm sort of spitballing. So.
I would also say that we're grappling with basically every single vendor that we work with is integrating some kind of AI component into their tool, and it sometimes works in different ways. So we're kind of trying to stay on top of all of those various pieces. And I think all of the major vendors are kind of like quickly licensing their content, so they're kind of siloed off. So it's very difficult to kind of comprehensively search these sources. Yeah. And I would also just kind of jump on kind of what you were talking about, like what we lose when we use AI. If you already have sort of the foundational expertise to kind of just have that intuitive sense of like what you're reading and what is right and what feels off. But if you're still developing that, I think there is a lot to be gained by just like muddling through the literature. And it kind of just depends on your use case and what you're trying to do. But if you're obviously many people are just quickly preparing for a talk or putting something together, so that makes perfect sense.
I mean, one thing I will say is that, when Google search, when people start using Google search initially, you'd have to click on the link and it would sort of take you to the link and you'd read the link and maybe it wasn't quite right and you'd learn that back and forth. And then Google became crap and started using AI overviews for everything, and no one bothers to check the sources anymore. The AI overview. I mean, I've been guilty of this too. I've been searching on my phone. Oh yeah, it's the AI overview. It's for something I don't care. I just want to win an argument with my friends about some sports statistics. So as long as it says I'm right, I don't care. So I just use that. But this is the problem. You lose that sense of I should check the sources goes away when the answer is presented as reliable without pointing. And I think the big pushback from a few years ago with hallucinations forced all the major chatbots to incorporate a fair amount of RAG so they could do citing of sources. It's still not great, but there was progress, right? I mean, the fact that people are saying this stuff is just making shit up and it doesn't, excuse my language, and it doesn't actually, give me anything reliable. So, okay, we need to put RAG and we need to make it reliable. Open evidence is a great example because I've talked to doctors who use open evidence, and that's exactly the point. It's JAMA, it's New England Journal of Medicine, it's reliable sources. And I suspect they've trained the model to express a lot of doubt and uncertainty in the answers. Like one of my friends was showing me the answers it gives, and it doesn't make categorical statements like this is the answer, like, well, this is what the evidence says, and it could be this or it could be that. It's been trained to do that. So it's not like we can't have good things. Someone needs to build them for us. Yeah. And so I think that's something to keep in mind with this. I mean, a lot of what I say sounds very pessimistic, but I'm also saying we should demand the things we want and make someone build it for us, and there's a market for it. I mean, Open Evidence is a huge company now. And it's not one of the big three, big four sort of companies doing this work.
No, I was just, because Professor Round talked about is it cheating, and you just addressed the idea that, oh, librarians are against Google or librarians are against Wikipedia, and now librarians were against AI.
Yep.
And I think it's more, as you said, it's just to be critical of, using these tools to explore and learn more something about, and then still keeping the agency and responsibility to verify that those citations are correct and they're not writing the work for you, I think. Just, I think that's important to know that we're exploring how to use these tools for literature searching. We sit down with students and we ask them to generate keywords that match to a title, an abstract, an author keyword. And sometimes folks don't necessarily have deep expertise in those areas, but we ask them to come up and generate those topics. And now some of these tools can sort of help us extract, synonyms for different ways to describe AI. So general artificial intelligence, chatbot, like all of these strings that one might put into a database. So we're trying to find the positives, I think, at this point in the library, so that we're not necessarily trying to tell people that we think that AI is inherently cheating.
I'm gonna run across the room.
Yeah, great talk. I'm curious about your role, or the role of what I would call empirical research in the face of all the development of AI, because AI is, large language models are operating on a training set and applying it to a bigger data set. So it's all essentially based on knowledge that already exists. But I think all of us who are involved in biomedical research are working on questions we really don't think are known. And so there isn't a way to sort of train that, in a sense. So the way genes interact with genes inside a genome, or the way cells interact with cells in a tissue or a disease, or the way organisms interact with the environment, a lot of that is totally empirically unpredictable. Epistasis and gene-environment interactions are inherently unpredictable. So I'm curious, how does AI help us with that, or does it actually allow the empirical components of research to be that much more important? Because those are things we really can't predict. So how do we use AI to address that problem?
So first of all, I don't specifically know the answer there, but I can shed some light on this. So a week ago or so, we had Jan LeCun, who's one of the Turing Award winners for the development of deep learning, come and visit Brown. And he used to work at Meta, and he's moved on to sort of start a new company around this whole idea of what he calls world models. So a lot of the premise of the folks working on world models is that LLMs, because they're based on text, because they're based on historical data, can only take us so far in our understanding of the natural world. And that we need something different to access information about the physical world, right? He would like an LLM or he would like a model to essentially learn what gravity is, and sort of be able to model gravity through observation, say, of videos of things, lots of things falling in different ways. And his argument is that we don't yet have the technology to do that. So his answer to you would be, we don't yet know how to do those things. And in your case, it sounds like it's even harder, because there isn't maybe a natural law we can rely on, but some very complex, I don't know, maybe a differential equation or something else stochastic that's explaining what's going on inside the cell. And so he would say we're not there yet, and that these tools right now cannot help us do those things. But his goal is to build systems that can do that. We'll see what happens. But I think this tension between, what is it about the world that can be conveyed only with text corpora, what is missing, and what do we need more of, is where some of the academic research is going right now.
I just wanted to pick up on your comment that we should demand more.
Yeah.
I mean, I think this is absolutely right. Every day we hear from the CEO of some AI company that AI is going to destroy us, essentially. And yet they're the ones who are doing that, right? So I'd love to hear a little bit more. I mean, you talked about open evidence. I'd love to hear a little bit more about how they could do better, and how we can demand more as individuals, as an institution, as academics.
Yeah, it's a great question. And I direct a center for tech responsibility. Actually has many R's in it, but two of the other R's are Reimagination and Redesign. And one of the things we think about is, it's not enough just to whine. We do a lot of whining. We don't not to complain about things that are out there. We have to suggest a different way forward, right? And we have to build, and in some cases, because I'm a computer science, we can build the thing we want to see, maybe at least as a prototype. So to your point of how we do this, it's hard. I think, it's always been funny to me that, tech CEOs will say things like, AI will solve world hunger, will solve this, and we'll ask for one small thing, oh no, that's too hard, we can't do that. It's funny how they could go back and forth very quickly. And over the years, some arguments have been, okay, we need legal incentives, we need pressure, we need sticks. Some of those incentives are less effective right now. So there may be other, let me give you an example. So over the past summer, when those two kids tragically sort of committed suicide after interacting with a chatbot, created a kind of weird switch in the public sort of perception. You could almost feel it, the public opinion changing on a dime. People went from, wait, these AI tools are cool, to like, what the heck are these tools doing to us? And people start saying, we need more, we need more protections against these tools. So one of the things that I do at the center is we track AI legislation in the states. There's been a ton of bills in the states on topic of AI companions, so trying to protect regulate the use of AI companions in various ways. And they've gone different directions from a policy point of view. But the fact that they've even been introducing these bills is in reaction to people saying, we don't like what's happening and we want something better, right? That has multiple effects. It causes legislators to react in one way, but it also opens up opportunities for maybe smaller companies. So, here's a window I can start going to. I mean, I don't know what the history of open evidence was, but I presume they came into saying there's a gap here. There's a need for something useful. They presumably talked to doctors, said, this is what we want. We don't want what ChatGPT is selling us, and they built something. I was just on a panel with a lawyer who's built a tool called ClearBrief that is trying to assist lawyers in the drafting of briefs, and their whole focus is on getting rid of hallucinations. Right? So, and the way they do it is not by saying we have a better tool to not have hallucinations, it's by changing the entire interface. They don't say, here is a prepared brief for you with all the citations. Here's like, no, here's your document. Here are all the things you have said that require citations. Here is click on this, this gives you a document. Please go check and see whether this matches what you want. So they created an interface to make it easier to do what you want. There's a lot of creativity in computer science. There's a lot of creativity in what my colleagues do in trying to build systems. We can build whatever we want. But sometimes we need some help knowing what we should do. And that's where people who actually use systems saying, no, your system is crap, I want this, build this for me, I know you can do it, helps us say, okay, this is what we should build to help you. I think that dialogue should happen a lot more. I think we need a lot more small AI and not a lot less big AI. And that's where we will get tools that are actually useful for us.
Thank you.
With any additional questions, please join us for the networking event. So we're now going to move to the awards ceremony. And I want to say that historically, one of the highlights of the IDeA Symposium each year is recognizing the outstanding work of our trainees and the early career investigators who are highlighted. And this year's presentations have been truly exceptional. Across both the poster sessions and lightning talks, we've seen innovative science, thoughtful application of new methods, including AI, and a clear commitment to improving the health and advancing knowledge, especially in the state of Rhode Island. Selecting awardees was not easy, and we want to emphasize that all of our presenters should be proud of their work. What stood out most was not just the quality of the research, but the ability to communicate it clearly, concisely, and with purpose and passion. That skill is essential, especially in today's research environment, where our work must inform practice, policy, and public understanding. To all our presenters, you are part of a generation of scientists that is collaborative, interdisciplinary, and poised to lead the future of research. We are excited to see where your work takes you. Now, it is my pleasure to recognize this year's award recipients. Please join me at the front of the room as you hear your name. And I received an envelope just a few moments ago. And so, and next year we'll have a red carpet, but maybe not. So for the poster presentation winners, please come forward but please hold your applause until all three are announced. So we have AI-informed prioritization of assistive grip device development by Amanda Toledo and Dr. Nicole Urban with the RI-IDeA. Please come forward. Next, hold applause, please. AI-supported development of a needs index to inform state-level assistive device policymaking. Sadie Davignon, Val Rosario, Haley Soares, also Rhode Island INBRI. And third, a needs index to support adoption of novel field-based TBI detection device for first responders. I'm getting a trend here. Samantha Davey, Colin Laidlaw, and Dr. Nicole Urban, Rhode Island INBRI. Thank you.
So excited! Thank you.
Thank you. Very well done. Moving on, our three Lightning Talk Award winners are the following. Again, please hold applause until all three are read out. First of all, Signals and Data, Leveraging Computational Approaches to Identify Suicide Risk Cases in the Electronic Health Record, Dr. Sarah Arias, Department of Psychiatry, Human Behavior, Brown, who may not be here. AI That Tells Us Why, Interpretable Models for Clinical Medicine, Dr. Alina Barrett, University of Rhode Island. Barnett. Okay, typo, sorry for the typo. Design of the Smart Cart 2.0 platform to promote healthy eating, Dr. Maya Vadavito, University of Rhode Island. Terrific. Congratulations to our awardees. And at this point, I want to thank everyone who contributed to making this symposium such a success, and especially our partners in the Rhode Island IDeA programs, and certainly also the incredible staff in the admin core at Advanced CTR that really helped with all the logistics and making this program very successful. I want to mention at this time, as we are closing, that you, as registrants, will be receiving a survey about the symposium. This will come by email, and we would appreciate your feedback so that we could improve the presentations and so on in the future. So now I can certainly invite you to join us on the third floor for the cocktail reception and the opportunity to ask additional questions and network with our keynote speaker from this afternoon. Very good. Thank you.